Gyroscopes are very interesting objects as they seem to defy gravity. They are essentially devices with spinning disks that work based on the principle of angular momentum. The reason why they seem to defy gravity is because the weight causes a torque acting in a direction parallel to the disk, thus making the gyroscope rotate around in a precessional motion. These principles can be illustrated when using a fidget spinner since they are like little gyroscopes. When you rotate the spinner in a way that's not parallel to its rotational axis, you can feel resistance from it, and this resistance is known as the spinner's gyroscopic precession. The first problem we have is about the torque of a gyroscope. As we can see here, we are given the radius of the rod and the mass of the disc. We also have to take the force of gravity into account as it plays a role when calculating the torque of this gyroscope. Then we can find the torque using the equation given to us. The second problem is about finding the precessional velocity, which is represented by the symbol omega, of a gyroscope. Here we are given the small omega, which is the velocity of the disk, and we are also given the radius. Like the previous problem, we also have to acknowledge the force of gravity, or just gravity by itself, as we need it to help us find omega. We can now find the precessional velocity using the given formula here. A real-life application would be our planet Earth, as it does the exact same thing as a gyroscope. The Earth spins around about one rotation every 24 hours, and the rotation of the axes will spin around every 26,000 years, which is like a gyroscopic precession. Another real-life application would include the boats that we use today, specifically large boats, as they require these huge gyroscopes in order to stabilize them so that they won't rock too much and tip over. Gyroscopes are also found in modern aircraft, which are used to observe and control the orientation of the plane during flight. All in all, gyroscopes are very significant as they have helped us make some technological advancements in many forms of transportation that we use today. They are also useful in many different ways as they help us understand some of the many laws of physics and their applications to real-life scenarios. The end.